This conference will now be recorded.
Hello, everybody. Welcome to the Satellite Book Club Seminar Series. This is session number 32. Thank you for joining us today. I'm Jordan Girth with the National Weather Service, Office of Observations. We've got a great presentation from Pam Sullivan, the GOES-R and GeoXO Program Director. And our facilitator is Linda Gilbert, a lead meteorologist at the Weather Forecast Office in Marquette, Michigan. The title for today's talk is Planning for NOAA's Geostationary Satellites in 2030 to 2050, the recommended GeoXO satellite system. Just a few reminders before we get started today is that this session is being recorded. Please stay on mute until we get to the Q&A. There will be Q&A after the presentation, and we encourage you to post questions in the chat room, and that will help us field them in the order they were asked. We're always looking for future presenters to the Satellite Book Club, so if you have a unique application to share with the field, please get in touch with us. There's also a training team that can help create training materials or help you find training materials for satellite data and using satellite data in operations that may be unavailable. Contact Brian Mata for information or questions regarding that. And thank you to the Tower S team, particularly Kashad Bowman, the Office of the Chief Learning Officer, GOES-R and JPSS programs for their support of the Satellite Book Club. After Pam's presentation, we will have a unique aspect of today's Satellite Book Club. We have a few questions for you. We will be sending out a link to Slido, and you can use your computer or your phone to answer a few multiple choice questions. And those questions will be geared to our National Weather Service participants today. So please be ready for that upon conclusion of Pam's presentation. Without further ado, I'd like to introduce Pam. Pam Sullivan oversees the development, acquisition, integration, installation, and acceptance of major system elements such as spacecraft, instruments, launch services, and ground systems for the GOES-R satellites. Pam joined NOAA in 2018. Previously, she managed the GOES-R series flight project for NASA, directing the development of the spacecraft, instrument, and launch services for the 4 satellites in the series. Prior to her career at NASA, Pam served as an officer in the U.S. Air Force, training as a space shuttle flight controller and supporting military space experiments using the shuttle. So Pam, welcome to the Satellite Book Club, or I should say welcome back.
Oh, thanks, Jordan. Thanks very much for having me back. So, and thanks to everybody. It was last August, I think, we first came and introduced GeoXO. So we've been doing a lot of work since then. So this is to try to catch everybody up on where we are with GeoXO. Let's see. But first, I wanted to start with a little bit of indulgence. 90-second movie here. Tim Loomis of the Viz Lab put together the 2020 Atlantic Basin hurricanes, or I'm sorry, tropical storms. So 30 storms, 3 seconds each. So just a recap, and I think you know, not that this audience needs it, but a good reminder of the criticality of the geostationary observations. So yeah, Laura, obviously one of the big ones striking there. Just a lot of storms, and you know, we've got a lot of movies where you pull back and you see, you know, 3 or 4 or even 5 storms happening all at once. So again, I thought this was a pretty awesome video. And you know, my other thought on this, the fact that we had 30 tropical storms last year and that wasn't a big news item tells you something about the news landscape in 2020. But in any case, you know, here we are deep into the Greek alphabet here. Nice organized storm there. And Eta, this was one of those the first one that hit Nicaragua, and then coming up Iota, you know, striking that almost exact same location. So anyway, great movie here. Download the slides and you can have it if you're interested. Okay, with that as an introductory, I think we showed this last time. This is the flyout chart, of course, shows that GOES 16 and 17 will be operating over the time frames with the green bars. The blue bars are the next 2. We are still on track to launch GOES T late this year. And then it'll go into service, and then GeoXO will be launched in 24, and then it'll go into service. But then our need date for GeoXO is really set by when we lose the third to last of the GOES-R series. That's when we lose our on-orbit spare, and so that's our target date for the launch of the first GeoXO. And we showed this last time. If you're paying close attention, you probably noticed that we changed the acronym a little bit. We had been calling it Geostationary and Extended Orbits because we were thinking about putting satellites in tundra orbits or other places, and it's now Geostationary Extended Observations, because what's really come out of the formulation activities that we've been doing over the past year is not so much that we want to take the observations we're making now and put them in new orbital regimes. It's more that we want to take observations of different phenomena. So we're expanding the types of observations that we hope to make with our geostationary satellites. So hence the name change. So GeoXO still includes all of the NOAA Earth observing assets above LEO. That is, of course, government spacecraft. It may include instruments that we contribute to others. There is some discussion ongoing still with Canada about a potential mission that they might fly in highly elliptical orbits, and so we might contribute instruments to them. And the time frame that we're looking at, this is the same as when we talked to you last. We are getting very close. Our mission concept review will be in March of this year. That'll lead to system requirements review next year, a preliminary design review in 25, critical design review in 27, and then our first launch in 32. As mentioned, a busy last year. We have come away with recommended observational priorities from the team we call the Zorwig, our science experts that were the GeoXO User Requirements Working Group. They have been doing a lot of workshops and conferences talking to users. They've also been doing a really excellent job documenting the observations that we plan to make, what the applications will be for those observations, and what the expected benefits will be. So a lot of good work to help write all that down and be part of the justification for the system. Another major thing we've been doing, industry studies. They've been helping us look at particular instrument designs, in particular the imager, infrared sounder, microwave sounder. Industry's also been helping us look at some of the non-traditional options, the idea of doing a LEO swarm of satellites, commercial hosting, commercial data purchases. And so those studies really, I think, did give us a good sense of what the capabilities could be, what the costs could be, what the risks could be for all of those different options. So those were very helpful. In parallel, the program has also been studying instruments. We've been looking at sounders also, but also ocean color and atmospheric composition instruments, as well as some technology needs for the Lightning Mapper. And all of that has kind of led to, again, defining the observations we want to make, the requirements for the system, and we've also got cost estimates at this point as well. So I think I showed this last time. This is the sort of a sample of the range of constellations we were looking at. Each one of the rectangles represents a spacecraft. So, so in each box you see you've got, spacecraft with instruments on them. We go from constellations with 2 to 3 to 4 to many spacecraft. The yellow boxes were the idea of looking at hosted instruments. So we put one of our NOAA instruments on a commercial host. We were looking at disaggregated systems where we fly, instead of a couple of big satellites, many small ones. The green boxes was looking at the idea of buying sounding data, either in addition to or instead of having a NOAA sounder. And then the LEO swarm option as well. So again, just a smattering of what we were looking at. And for all the constellations that we were looking at, our Zorwig, our science team, helped us define what the observational value was of that constellation. And they did that by coming up with a numerical score for how each of the instruments supported the NOAA mission service areas. And then each constellation got a score depending on which instruments it carried. So you see we end up with a graph that shows sort of the value that the constellation provides and the cost. And so we did several iterations of this. We did a first set of constellations that gave us some impact about, or some feedback about what was going to be a good solution versus not. We refined the constellations, and in the end came down with sort of the highest priority observations and was looking at the best way to accommodate them. And all of that data feeds in to the recommendation that we're making, which we introduced this at AMS this week. And so what you see here, obviously the first thing you notice is there's 3 spacecraft instead of the traditional 2. We still, of course, have an east and a west spacecraft. We are recommending that those spacecraft carry the imager, the lightning mapper, so just like those are, and they'd be joined by an ocean color instrument that will help ocean service and the fisheries do the kind of measurements that they feel they need to do, as well as their users. And then the 3rd spacecraft, nominally in the center of the country, we're still debating exactly where it might go between 90 and 105 west. But that spacecraft will carry the hyperspectral IR sounder and an atmospheric composition instrument, which is in particular championed by the OAR team that's looking at things like air pollution in order to do warnings for people's health, and they can also do climate related measurements with that instrument. And that 3rd spacecraft in the middle also has room for a partner payload. There's a 3rd instrument that can be hosted there. It's not defined what that is yet, but that is there will be accommodation for that 3rd instrument. And so out of all of this work, what really came down is that there were a set of observations that we think are critical to be made in the 2030 plus time frame, and they really wrap in this idea that the Earth is an integrated system. We do want to be measuring weather, and so this system will be improving our capability to predict weather, but it also expands those observations out to ocean and atmospheric composition to get a more comprehensive view of the Earth as a system. And so the day-night imager is one I hadn't mentioned. That won't be a unique instrument. We are anticipating that's a capability that can get added either into our sounder or to our imager. And so the constellation that we've came up with does support all these observations in a low-risk configuration, and the cost estimating that we've been doing so far tell us that we think we can afford this at approximately the same level of investment as went into GOES-R. So coming up, of course, still a lot of work to do. After we go through our mission concept review in a couple months and into the first approval gate, which is milestone 1, we'll be starting phase A of the program, where we're still formulating, still making decisions about the program. And so some of the key things that we want to learn in phase A are listed here. For the imager, we are looking at upgrading relative to ABI. So from the 16 channels we have now, we are looking to add a green channel and perhaps a few more channels, perhaps as many as 22. And we're also looking at improving the spatial resolution. We know for the 3.9 micron channel, in particular, we want to go from 2 kilometer down to 1 kilometer for better fire detection. We'll also be looking at whether we can put a day-night band capability in that imager. The The other option for the day-night band is in the sounder. One of the other things for the sounder that we want to look at is whether or not we can add the capability to monitor methane, which is one of the key climate measurements that are desired to be made. For the lightning mapper, we are looking at improving the spatial resolution. We are looking also at going from kind of the single telescope version that we have now into a 4 telescope version, more like what EUMETSAT is planning to launch in a couple of years, or next year, I guess. And then the new instruments, Ocean Color, our trades there are looking at whether we have discrete spectral bands versus a more hyperspectral spectral coverage. And atmospheric composition, we're looking at whether it's a UV-only instrument or Vis plus UV. So I put the imager specs in here. I know some folks will be interested. Obviously, I won't go into them in a lot of detail. But on the left are the baseline requirements that we're asking our contractors to study in Phase A. You will notice there is the green band in there. There is the spatial improvement for the 3.9 micron channel. And then as you go to the right, there's priority 1, 2, and 3. These are upgrades that we're going to be studying in Phase A to understand which of these are feasible. And out of the Phase A study, we will have a sense of which of these are doable on the schedule and the budget that we think we can afford, and that will help us set the requirements for the implementation phase. So a little bit about the sounder here. We are looking at 4 kilometer spatial resolution. The blue bars show you the wavelengths that we're going to be studying in Phase A. Some specs there about the day-night band as well, looking for a half kilometer performance. And the lightning mapper, up top, you see that what we are currently getting with our 2 GLM configuration. At the bottom shows you what we think we could get with an upgraded lightning mapper. So this improves the spatial resolution at nadir to 4 kilometer. And with that 4 telescope design that I mentioned, really gets us almost all the coverage with a single lightning mapper that we currently get with 2. Although you do see that there's more variability across the field of view in terms of spatial resolution. And so we're just beginning. Lots of caveats on this presentation. Nothing here is officially approved, but we are working to establish a baseline, take that into our mission concept review, and then milestone 1, where DOC would officially approve the start of the program. After that, all the Phase A study contracts that I mentioned, those will happen over 21 into 22, help us refine requirements going into the system requirements review in 22. And then that will help us define our acquisition strategy, go into the next milestone gate where the program would be officially approved. And that's the gate that would take us into awarding implementation phase contracts. Top level schedule for those that are interested, it does contain everything I just talked about. Milestone 1 this year, milestone 2 next year. The dark green bars are the implementation phase contracts for the instruments and spacecraft. So you can see we're trying to get those in place starting in 23, and we really need to have them in place at about that time frame in order to make our planned launch in 32. And so this is a list of things we've got going on this year. If you're interested, on the left are the procurement related activities. So RFPs and sort of outreach that we definitely want our industry partners to know about. On the right are more of the user engagement activities. We spent 2020 asking users to come in and talk to us. In 21, we think we're going to go out to users and kind of meet them in the forums where they're normally in, which will help us communicate our GeoXO plans out to a wider audience, as well as help us understand more about what our users need through their eyes. And in summary, we are planning for the next generation, hoping to start formulation in a few months, and definitely look forward to working with all of you to help develop GeoXO.
Okay, thank you. Excuse me. Thank you so much, Pam, for that great presentation. There's a lot to look forward to in GeoXO, and from my perspective in the Office of Obs, we've really appreciated working with you, and we're going to continue to work with you through these Phase A studies to figure out what the best design and value for the Weather Service and for NOAA is. So thank you so much. We do have a few questions for the audience now, particularly our National Weather Service audience. And you can see there on the screen, if you could go to slido.com and use the event code SBC. There's also a link in the chat. Again, we're targeting our Weather Service participants on this call. We'd like to get your feedback on just a few things. You can do this with your web browser on your computer or through your phone. There's no app to download or anything. We're not collecting any user information about you, so don't worry about that. This is the first question that's up there now. Once that settles out in about a minute, we're gonna have two other questions coming up. I'll sparse them about a minute apart, so please feel free to answer them. And now I'm gonna turn it over to Linda to lead our Q&A. Linda.
Hi, good morning, good afternoon, everybody. And it looks like we've already got some great questions that are starting to come in on the chat. So if I may start off with this conversation here, Pam, one of the questions that came up on chat, as well as something that popped up here, is from Alicia specifically. She had asked, so do none of these carry space weather instruments? So can you talk about space weather instruments and how it fits into the constellation? And will there be additional satellites launched for monitoring space weather?
Yeah, great question. And this is a change from GOES-R to GeoXO. NESDIS is actually establishing a separate space weather program, so there'll actually be a different organization that will be making these decisions really about what the space weather observations are and what spacecraft they're manifested on. We do anticipate, and in fact for our mission concept review, the Space Weather Program has asked us to baseline that we will be carrying the future equivalent versions of the same instruments that are currently on GOES-R. So the magnetometer, particle detector, and then the 3 solar viewing instruments. They have said they plan to provide the next generation version of those to us and want us to carry those on our East and West spacecraft. And they may, let's see, folks probably know, there's already plans underway for Space Weather Follow-On to put a Space Weather Observatory at the L1 point. And so we do anticipate the future Space Weather Program will also have follow-ons to SWIFO. So we anticipate having that same presence at L1 in the future. And the Space Weather Program is also in discussions with the Europeans about possibly providing instruments or being a partner on European missions that go to other places like L5.
Okay, great. And then that actually ties into another question here. How are international plans, such as from European, Japan, et cetera, considered in the development of the constellation? Can you talk a little bit more about that?
Yeah, absolutely, Linda. So I think folks know about the World Meteorological Organization has put out their vision for 2040 of what they recommend meteorological agencies do as far as their space observations. And so from a GeoXO perspective, we are looking to WMO's recommendations for what they recommend be in a geo orbit. You know, the concept there for GEO is that there is a ring of geostationary satellites that surround the globe that are more or less taking the same kinds of measurements. And so GeoXO will be fitting into those expectations. WMO in particular is asking for imager, lightning mapper, infrared sounder, and atmospheric composition instruments to be in that ring. And so this will meet their needs. And then in terms of talking with individual partners, we are actually, you know, we're talking with all of them, of course, but we're interested in the Europeans because they're actually going to have an IR sounder up ahead of us. So we very much hope to learn from their experience as we develop our IR sounder. And for Japan and Korea, their schedule is more closely aligned to GeoXO. They are looking to launch their next generation system towards the end of this decade, which means they're kind of in the same phase that we're in right now of deciding what exactly they want their systems to do. And so it's very helpful for us to compare notes with them and for them to understand what we plan to do and try to, you know, everybody move towards the same kinds of systems.
All right, great, thank you. So we are starting to approach 12:30 here. We've got just a couple of minutes here to go. So I do want to just take a moment here to pause this discussion. There's so many great questions that are coming in, but let me toss it back to Jordan here. If you want to go ahead, Jordan, and take over.
Okay, thank you so much. And please continue to answer that last Slido question. I realize that some of you do have to depart at the bottom of the hour, but we are going to continue this discussion for at least the next 15 minutes or so. So please stay on and we will get to your questions if you are able. If you are not, I hope you'll be able to join us next week. We're going to have another great presentation again at 12 noon Eastern time on Thursday, January 24th. Nick Laneley, the Science Operations Officer at the WFO in Marquette, will discuss lakeshore flooding impacts, and look for that email from the Tower S team. You can also, we're always looking for your feedback on the Satellite Book Club. Please provide us your feedback at the link in the chat. So with that, I hope everybody's staying well and that you'll be able to join us next week. And now I'll turn it back over to Linda and Pam for more questions on GeoXO. Thank you.
Great, thank you so much, Jordan. All right, Pam, the questions just keep on coming in. So we'll just keep going down here. So one of the questions here from Steve asks, how are the desired requirements or capabilities of the GeoXO Ocean Color mission different from the HES CWI Ocean Color demanifested from GOES-R?
Steve, you know, I'm not sure exactly what was planned in the HES CWI. What we are planning for GeoXO Ocean Color is modeled on an instrument that NASA's planning to fly called Glimmer, and it's a hyperspectral ocean color instrument that they're designing, and they plan to launch in about 27. So we're looking to that for our specs.
All right, great. The next question here is from Mark. If the DNB was on the sounder, would it have lower resolution than if it was on the imager?
I think no is the short answer. We're looking for a half kilometer, I think, in either case.
Okay. The next one comes from Joseph. Would the next gen lightning mappers for the GeoXO program have a background/baseline image taken more frequently than the current GLMs? And this is definitely a question along the lines that I'd like to have answered as well. Thank you.
I don't think that's been decided yet. If you've got opinions on that, we would definitely like to hear them as we think about what we want to ask our contractors to study in phase A.
Okay, great. The next one comes from Brian. Are true color RGBs specifically called out in the user requirements of November 2020?
The user requirements of November 2020. Let's see, we haven't, let me say, we've been focusing, I think, more about the hardware. You know, the instruments that we're buying will be able to produce those RGBs. We haven't really gotten to the phase where we're talking about the products specifically. So again, looking for your inputs for what you'd be interested in seeing there.
Okay. The next one, I know that you kind of talked about this a little bit already, but let me go ahead and ask this question anyway. This comes from Kenneth. Major similarities and differences with direction taken by Asia and EU new developments.
Yeah. Let's see, comparing to what we're thinking of GeoXO to Europe, you know, I think the imagers will be similar. I think our instruments scans a little bit more frequently, but very similar in terms of capability. The lightning mapper, we're probably going to evolve a little closer to their design. The IR sounder, the orange lines indicate their spectral coverage, so you can see the blue is what we're thinking relative to them. As far as the Japan, our anticipation is that they will buy a copy of whatever imager we plan. That may not be completely true, but to first order, that's, I think, our expectation. Japan is also very interested in a sounder. I suspect they will want something that either looks like the GeoXO or looks like the EUMETSAT. So I think there'll be close ties either way there. And I know Japan also wants a lightning mapper. I do think that's the third instrument on their lists, and they're not 100% sure they're going to get funding for everything on their wish list. But my guess is they would be looking to the European concept there as well. And they haven't really announced that. They're very much still collecting like quotes and input from industry. So that's why I don't know exactly what Japan's decided, because they haven't decided yet.
Gotcha. Okay, great. Thank you. The next one here comes from Derek. Can you tell us anything about the vertical resolution of the IR soundings?
No, I can't. I don't know. Jordan maybe be able to handle that, or I can get you an answer if we don't have anybody online that can step in.
Yeah, we should follow up with a better answer. It's going to partially depend on the instrument that we select and whether or not we have both shortwave IR and longwave IR components to it. You know, it's probably going to be consummate with what we get from Chris currently.
Thanks, Jordan.
Thank you.
Since we're on the subject of IR, I'm going to skip past Paul's question. I do see your question, but I am going to come back to that in just a second. I'm going to ask Brian's first. Is the planned hyperspectral IR sounder an instrument that has already been developed, or will NOAA be investing in R&D for a single instrument?
This will be a new instrument. There has been some work done in the GOES-R series. There was a Phase A study. I imagine the companies that were involved, 10 years ago in that are probably going to build on that. And we're also looking to, Europe's experience, but in general, this will be a new capability that we will have to invest in the design of for GEO.
Okay, great. And then it looks like there's a comment here from Dan. He says, I would expect the vertical resolution of the IR soundings to be on par with what is available from the polar IR sounders, similar to the NuCAP's algorithm. And then Lee just remarks, thanks, we will follow up. Pam, did you have any other remarks or anything like that along those lines?
No, thanks, Dan.
Okay, great. All right, and then let me go back to Paul's question here. He says, I'm still a bit unsure what GLM offers for a continental CWA over ground-based lightning data. And he has it in parentheses here, putting issues of CC versus CG aside, since we do have access to both data sets.
Yeah, again, probably a better question for our scientists to answer, but one new capability I think that's been a little surprising even in the last year is that the fire detection capability. I've been reading stories about how there were lightning strikes and then there were smoldering fires for days really before the fire actually caught. This was the story with a couple of the western fires this summer. So and people will be able to use the GLM data to say there was a not just a lightning strike, but a strike of sustained current. So there's a specific category or specific intensity of lightning strike with these continuing current that are most likely to cause fires. And so GLM can detect those and can help folks pinpoint where those fires might start even before they've started, which is a really interesting phenomenon, I think. And I'll let, if any of the scientists online want to jump in and help answer the more weather aspect of that question, I'd appreciate it.
Yeah, and it looks like Joseph here just put in a remark that is pretty much in line with something along the lines of what I was thinking as well, which is a minimum flash area and total optical energy. He says, I find both to be very useful GLM products, good for assessing convective development before it manifests on radar. So thank you very much for those remarks. And Brian also had said continuing current, so just kind of continuing that discussion there.
Yeah, this is Jordan. I'll also just add that the Weather Service is very interested in continuing current capabilities, and we're still building products from the GLM to make sure that we're capturing all the value that the current instruments provide. Over CONUS, we realized that there are multiple sources of lightning data, but particularly the land-based networks that certainly complement the GLM and provide slightly different information about lightning. Over the ocean, the possibilities and use of the lightning mapper is a little greater because there is a loss in detection efficiency over the ocean far from where those networks are positioned. And we're currently developing research to look at, for example, tropical cyclone intensification and how lightning behavior plays into that. Those are things we're going to continue to explore in terms of the future GLM and trying to maximize the detection efficiency so that you can have consistent information or rely on it consistently everywhere throughout the contiguous US.
All right, great. Thank you, Jordan. And again, along the same line here, Dan makes a remark here. It says, Paul, a team put together a value assessment for GLM. We can share that if you want. We feel that geo lightning mappers can be especially helpful over the ocean where the ground-based networks have lower detection efficiencies. This is helpful for aviation and marine applications, which many of you may not necessarily think, for example, my CWA, half of my CWA is marine, Lake Superior, so I can definitely attest to that. And there is promising active research for use of GLM data for data assimilation, particularly over the ocean, and then of course the Great Lakes as well. And then Brian just adds another remark in here. GLM provides the background for optimizing the use of ground-based networks, which will be realized in AI processing and data fusion with other sources for facets type real-time probabilistic warnings. So thank you both very much for those remarks.
Yeah,
Any other questions coming in? Sorry, Pam, go ahead.
I was just going to say, Dan reminded me Scott Rudlowski led a team that put together that value assessment. It was a lot of different applications I hadn't really appreciated. The lightning mapper, they made the case, and we really should get it out to folks, that it can help with understanding precipitation levels, where we're going to have more versus less. Yeah, a lot of very different kind of applications. Also, lightning is a climate variable, so hotter planet, more lightning. So a lot of different interesting tie-ins with that instrument.
All right, there's definitely some excellent discussion here. Thank you very much, Pam. Any other questions? I'll give it just another minute. If you're typing up your question here, we are going to be wrapping things up here in just a few more minutes. Anything else here? Okay, not seeing anything so far. Pam, did you have any final remarks before I turn it over back to Jordan?
Just to say that we need everybody's help. As I've said before, this program isn't approved yet, so the more people we get excited about it, the more people looking forward to these new applications. You know, that enthusiasm will translate into people wanting to build it. So, so appreciate everyone's help.
Okay, thank you, Pam. Thank you, Linda, and thank you for everyone for being with us today for this great presentation. We're going to keep you informed about the progress of GeoXO as we go throughout this year and into the future years of mission planning. This is going to be a very exciting time, just as it was exciting before the launch of GOES-R. I want to thank you and reflect just momentarily on the answers to the Slido questions that our Weather Service colleagues on the call today received. We see very clearly a lot of interest in routine low light visible imagery and improved satellite sensing in a pre-convective environment. Those were just about tied. We're seeing that the lightning mapper currently is meeting a lot of needs for improved lightning detection. So that's good to see as well. And we're going to take this under consideration, meeting with Dr. Uccellini about how our field is going to be using GeoXO and envisioning use cases, and this feedback you provide is very useful in that way. With that, I think that's all for today. Please get in touch with our Tower S team if you need any assistance getting your AWIPS configured for some of the new satellite products that we have now from GOES-R and JPSS. And as I mentioned earlier, please join us again next week for another great presentation. This next week's going to be on lakeshore flooding. Until then, take care and stay well.